So there's always been a tension in my mind between what constitutes an open-ended system, organism, whatever, and an AI, right? Because if you're gonna take open-endedness seriously, then it's just, it's something that will just grow and it will kind of just do its own thing. You can't really, there's not much of goal directedness. There's certainly not like an error function for such a system, or at least the pure version of it, right? So case in point, LLMs versus a substrate that runs the six primitives. One is a system that minimizes an error function, and the other one is a system that runs a bunch of operations algorithms on a substrate, and interesting stuff comes out. So what if you wanted to build an AI using the six primitives? You better have a good sense of how these things connect, or if they do, how do they overlap? And I think if you approach this naively, you might start thinking about, okay, maybe an open-ended system combined with evolution, and the evolution is pruning the open-endedness that's not useful. But really, you got to be careful here. What's useful? The second you say useful, is like useful to who? Like to what observer? So I think you owe to take a very big step back here and say, all right, say that the six primitives run emergence, and physics is emergent, mathematics emerge, and everything emerges through these operators. If we're gonna believe that, then everything is kind of intelligent. And then if we're gonna believe that, then the question of designing intelligence or making something intelligent is more of a question of making it appear intelligent to us. And what does that mean? Most likely, or at least to me, it means like a multi-theory structure that looks a lot more dynamic to us. So say, it's definitely not like a quantum theory type of thing where it's just one layer doing one thing that looks completely static through the billions of years. It would have to be a much more multi-layered dynamic, theories being born, dying, whatever, emerging, maybe even graph kind of structure, or a stack, I don't know. So that's one thing, and that suggests that intelligence is a matter of perception, right, as Levin would say. But that doesn't mean that's not to undermine it in any sense. It's just to say that we're not designing something intelligent. We're making something that feels intelligent, that that is certainly more useful, but it's definitely a different way of thinking, if you want. And the second thing is goal directedness and the error function that LLMs have, and an open-ended six-bird system doesn't. Well, not at least by design. And I really wanted to resist the urge of introducing such a thing into such a system, because you can do it. But then the question is it still native? What are you doing? You're creating something that is trying to approximate a function, but then it's limited by the function itself. It just feels wrong. So I think the leap of faith that you gotta make there is that you're not, maybe what you're trying to do is not trying to minimize an error function. Maybe what you're trying to do is create a twin, like a digital twin of a theory that is already out there. Take language. Language is an organism by itself, so a collection of theories interacting with each other, higher level theories, lower level theories, whatever, graph, stack, I don't know, whatever it is. Then your task is not to find the error function. Your task is something qualitatively and philosophically different. Your task is to try to create a twin of the thing that is already out there that you deem as intelligent or useful. And if you can create a digital twin of that theory space inside a computer, then you have effectively created that theory in a digital substrate that can, do everything, that can evolve it forward much faster, due to the fact that it is applying the six primitives in a meta sense. It doesn't expect them to be, it doesn't wait for them to be expressed on the substrate, which no substrate can escape them. And an LLM is actually a good example of a substrate that does not escape the six primitives, and that, given a lot of computation, is an efficient way, or the most efficient way we have right now, to get those primitives to start expressing and building a multi-theory space. Still very inefficient, if you ask me. It's kind of like taking a big piece of marble and trying to create the Statue of Liberty by shaking it. Sure, you can do it if you shake it enough and just in the right way so the right pieces fall off, but I don't know, maybe a sculptor would be a better way to go. So yeah, so if you can take a step back and think, okay, intelligence, well, whatever we make is going to be intelligent, but what we're really trying to do is create something that is like very rich in terms of layers and theories and objects, packages that emerge in them and changing quickly. That would look very intelligent to us. So that's one requirement for this system. And then kind of like let go of that error function, whatever, and try to think of it in terms of trying to create a twin organism, trying to emulate what is already out there. You can then go on, create different things, create things that never existed, but just to get a first grasp of it on it. And I think I've been playing around trying to decode, to program such an organism for the past 15 days. And language was actually the first thing that I started playing with. And I think a good name for it is language theory model. So LTM for short. Because, well, it all connects back to what I've been talking about. You're trying to create a twin organism of a language. This is all about six birds and theories and stuff, so it's a theory, and it's still a model in the sense that the six primitives are not kind of left to the universe to express, but you are using them in a meta way to drive emergence much faster. So yeah, that's what I've been playing around, and it's a lot of fun watching this thing grow. Theories getting born. One of the things that I didn't know was going to happen is that I usually see theories, like I see bursts of theory creation, whereby the organism will be kind of like standing still, building new packages, objects inside theories, but not building new theories, and then all of a sudden, you'll see it growing like 2 or 3 theories in rapid succession, which is a very interesting behavior. Not sure if it's intrinsic or just a matter of the implementation, but it looks cool regardless. So yeah, that's it.